Hello everyone, I am Dr. Pallavi Ram. Welcome to my channel Probabilistic Revelations for Engineering. In this video, we will discuss probability of dependent events and a chain rule. So let us say there are two events A comma B, and these two events are dependent events. So in such a case, we write the joint probability, that is probability of A intersection B, as probability of A given B multiplied by probability of B. However, if A and B are independent events, in such a case, we can write the joint probability of A intersection B, as simply probability of A into probability of B. Now, let us say we have three different events, so call them as A, B, C, and let us say that they are all dependent. So in such a case, probability of A intersection B intersection C, this is again a joint probability, but this joint probability is for three different events. So to write this, we'll write this B intersection C as D. So we can substitute this as probability of A given D multiplied by probability of D. So this follows from this rule. So next, let us substitute what is D. So that is probability of A given B intersection C multiplied by probability of B intersection C. Now let us apply this rule once again for this expansion. So this becomes probability of A given B intersection C multiplied by probability of B given C multiplied by probability of C. So that means using the dependent event probability, that is this particular box equation here, twice, we could write the joint probability of three different dependent events. So this is called as a chain rule. Now let us say that these three events, in case they are independent, A, B, C, if they are independent events, so in this case, probability of A intersection B intersection C can be written as probability of A, probability of B, probability of C. So product of three different individual probabilities. So this comes by extension of this rule twice. So in this video, we are going to discuss probability of dependent events. So hence we will concise, or we'll limit ourselves to discussion on this particular equation, the chain rule of dependent events probability. So now let us see an example how this chain rule is going to help us in many problems. So let us say, for example, that we have a box, and the box comprises of 6 white balls and 5 black balls. So let us say that we want to find the probability of drawing a white ball, or let us say encountering a white ball by the third draw. However, let us have an assumption here that the ball which is removed, that is the ball which is drawn out, is not replaced back. Before the next draw. In my previous videos, we have done exactly this problem, but however, the assumption was the ball which is drawn out is replaced back before the next draw. So here the change of assumption shows that there is something else that we have to look into. So the ball which is drawn out is not replaced back before the next draw. So this is the assumption that we are going to make. So in this case, how do we find the probability of encountering a white ball by the third draw? So again, let us write what are the different situations in which we can get a white ball by this third draw. So first, maybe the first draw itself could have given us a white. So first itself we could have got a white. Otherwise, so first draw we would have got a black and second draw we could have got a white. So this scenario also satisfies encountering a white ball by the third draw, that event. So then one more case is, so first we draw a black, second also we draw a black, and finally the third draw we will encounter a white. So this is having a white ball in the first draw, and this stands for having a white ball in the second draw, and this stands for having a white ball by the third draw. So if we write B, B, B and W, that means if I go one more step like this, so this says in the first three draws there is no white ball at all. So hence this particular event does not satisfy what the question asks. So hence this is not a part of this question, I mean this particular solution. So to go ahead with this probability calculation, let us have some notations. So let us say X naught stands for drawing a white ball. And let us say X1 stands for drawing a black ball first and then white ball second time. So this is B1 and W2. So that means B1 stands for drawing black ball on first draw, and then W2 stands for draw white ball on the second draw. So similarly, let us say X2. Let it stand for B1 intersection B2 intersection W3. So B1 stands for black ball on the first draw, B2 stands for black ball on the second draw, W3 stands for white ball on the third draw. So now in this case, we are interested in the probability of either X0 or X1 or X2, because all these three cases, all these three different event categories, they all come under the question event, that is probability of encountering a white ball by the third draw. So hence we want to find the probability of this or this or this. But if we observe the first X0, X1 and this X2, they are all independent or they are all mutually exclusive events. Why? Because X0 includes all the events which have white as the first draw, and X1 includes all the events which have black on the first draw and white on the second draw. So definitely the events which form X1 are definitely not a part of X0. So same reason applies for X2 also. So hence definitely all these three events are mutually exclusive. So hence applying the axiom of probability, we can write this as probability of X0 plus probability of X1 plus probability of X2. So now calculating the probability of X0. So drawing a white ball on the first draw. So we remember that our box has 6 white balls and 5 black balls. So 6 fundamental or elementary events are a part of this X0. So hence the probability of this X0 will be 6 by total number of balls, that is 11. Now coming to X1. So we'll write the probability of X1 separately and then substitute there. So probability of X1, it stands for probability of B1 intersection W2. So let me write this as probability of W2 intersection B1. So which stands for probability of W2 given B1 multiplied by probability of B1. Now to write this expansion, we have one more option. We could have written it as probability of W2 multiplied by probability of B1. But this happens only if W2 and B1 are independent. But in this question, every ball that has been drawn out has not been replaced back. So hence, The moment we remove one ball, the total number of balls in the box will be different, and hence the sample space itself will be different. So, drawing a black ball on the first draw and drawing a white ball on the second draw are definitely dependent events. And that is why we should not use this option. Rather, we should use the conditional probability option because they are dependent events. Now coming to the probability of this is equal to, so probability of black in the first draw. So black in the first draw means we have 5 balls which are black. So 5 by 11 should be the probability of black, B1. Now coming to probability of W2 given B1. So this says that in the first draw, black is drawn, that is given to us. So when black is drawn in the first draw, by the time we come for the second draw, what we will be left with is 6 white balls and only 4 black balls. So hence this probability of drawing a white stands for 6 balls out of total of only 10. So the probability is 6 by 10 multiplied by 5 by 11. So you can see that this probability is different from what we have calculated in the previous case. So let us substitute this back as 6 by 10 into 5 by 11. Now same way, if we go with probability of x2, we can directly write this as probability of W3 intersection B2 intersection B1. So applying the chain rule that we saw previously, we can write this as probability of W3 given B2 intersection B1 multiplied by probability of B2 given B1 multiplied by probability of B1. So in this case, the answer can be written like this. So first time when we are drawing B1, so that means we have total of 6 white and 5 black. So B1 stands for B1's probability stands for 5 by 11. Now black in the second draw. So by the time we come for the second draw, you can see that it's given B1. That means in the first draw, it is very surely given that first draw has a black ball. So hence by the time we come to second draw, we have 6 white and only 4 black. So this answer happens to be 4 by 10. Now by the time we come to third draw, we will be left with, let us see this. So W3 probability given that B2 intersection B1, meaning we know that first time a black ball and second time a black ball have already happened. So that means we are left with only 3 black balls and we are left with 6 white balls in the box. So hence this probability can be written as white probability. That means it is 6 out of total of 9 balls. So the answer is 6 by 9. So substituting this answer, this is 6 by 9 into 4 by 10 into 5 by 11. So this is how we can calculate the total probability of the event where the event is the encountering of white ball before the third draw. Thank you very much. If you have liked this video, please subscribe and please do not forget to click the bell icon to receive more updates. Thank you once again.